Hi all, this is Swetha, computer science engineering student in Sedu Institute of Technology. In this video, I am going to present about support vector machine algorithm in artificial intelligence. Let's get into the topic. First, we have to know what is support vector machine. A support vector machine is supervised ML algorithm that performs classification or regression task by constructing a divider that separates data in two categories. The optimal driver is the one which is in equal distance from the boundaries of each group. The algorithm is more commonly used for classification than regression. In some articles, the SVM for regression is also called support vector regression. How does the support vector machine classifier work? As a starting point, let us consider a simple example with two-dimensional dataset. Suppose we have a dataset with two features x and y where each entry is tagged with one of two classes. Our goal is to build a classifier that can classify unknown points into one of these classes according to their features. The obvious way of dividing these classes would be to draw a line that separates the entries with yellow and green classes. But there is an infinite number of possible lines to draw. How can we know which one is correct? The best possible line that we can draw from the data in the training set is the one that has greatest distance to the boundary points of each classes. In our example, it is H2. Then, when we can use this line to classify points to each these class, the point that fall on the yellow side of the line will be classified as yellow. The point that fall on the green side will be classified as green. Look at the two pictures. Understand how we choose a decision boundary. First, we only pay attention to points on the boundary between two classes and can safely forget about many other. Now we perform a calculation. We linearly connect each pair of points on positive sides and the center of this line is equidistant from the class. Thus these support points on the boundary lines are actually the sequence container representing arrays. From now on we will call them support vectors. Finally, the line formed based on these middle points is our boundary line. In our example, it is a straight line, but it is also can be a curve. Now let's see hard margin versus soft margin in support vector machines. What does a hard margin mean? The hard margin means that the SVM is very rigid in classification and tries to perform extremely well in the training set covering all available data points. This works well when the deviation is insignificant but can lead to overfitting, in which cases we would need to switch to a soft margin. What does a soft margin mean? The idea behind the soft margin is based on the simple assumption: allow the support vector classifier to make some mistakes while still keeping the margin as large as possible. If we want a soft margin, we have to decide how to ignore some of the outliers while still getting good classification result. The solution is to introduce penalties for outfitting that are regulated by C parameters. Applying SVM to non-linear data. Now let's look at the complicated case where data cannot be separated with a line. What should we do if the data set's yellow tags are mixed with the green ones as in the picture below? The solution is to add third dimension to data. Here we add a third dimensional z-axis to the data. If we embedded data in the higher dimensional feature space, it's possible to find a classifier to separate the two classes. This is done by what's called a kernel function. Use cases of support vector machine. In computational biology, the detection of protein remote homology is a common issue in computational biology. In recent years, SVM algorithms have been extensively applied for solving this problem. Next is stenography detection. With the help of SVMs, you can tell whether a digital image has been altered or contaminated. Face recognition. The SVM classifier divides the elements of image into face and non-face categories. First, it is inputted training information for n into n pixel. Then it separates the feature for each pixel into face or non-face categories. Text categorization. Using training data, the support vector machine classifies the document into many categories including news stories, emails, and web pages. Image classification. SVMs can classify images more accurately compared to traditional query-based refinement system. Handwriting recognition. SVMs are used to read handwritten characters for data entry and signature verification. Advantages of support vector machine. Resilient to overfitting. Except for the points closest to the plane, most of the remaining data becomes redundant. When working with these boundary points, we can intentionally allow some outliers to be misclassified to see the big picture and determine the optimal hyperplane. Simplified calculation. Once the hyperplane is built, we can assign a class to the data point located in the classified area without the need to calculate the distance between each point. The SVM algorithm doesn't work well in the following situation. When the dataset contains a lot of classes, when the dataset contains lots of noise, and the target class overlap. Thank you.